Now let me introduce the third presenter. Rebecca Yeo is a member of the Math Core team at DAS. She conducts student workshops and talks with parents to provide them with strategies to help her children with mathematics at home. Rebecca is currently pursuing her Masters of Education in Mathematics at the National Institute of Education. Please join me to invite Ms. Rebecca Yeo, Senior Educational Therapist, to present her research on evaluating the progress of dyslexic children on a small group maths intervention program.
Hello. Oh, great. It works. Okay, hi, good afternoon, and thank you for choosing to be here. So, as introduced, my name is Rebecca, and I'm a senior educational therapist with the DAS. So, what I do as a senior educational therapist, or actually as an educational therapist, is I teach primary and secondary school students literacy. But on top of that, I also teach mathematics to students with dyslexia at the primary school level. Okay, so not all of us here have dyslexia, but we all, at some point in our lives, do work closely with people with dyslexia. So at this point, I'd like you to have a little experience of what it's like to be someone with dyslexia trying to solve a word problem. Okay, so just a disclaimer, you might experience a bit of discomfort for the next 40 seconds, but please bear with me. And if you're ready, please try and read this word problem. Okay? Can? So how do y'all feel now? Actually, by looking at all your faces, it seems that many of you look like that. Sorry. Many of you look like that. Like, what's happening? And actually, this is something that's quite real for many of our dyslexics. Not many of them would have reversals, but some of them do experience the shifting in the letters as they read. And because this happens not just in math, the education system in Singapore is very, very language-based. So this kind of problems happen also across other subjects like English and science. And sometimes it gets so serious that our kids give this kind of response. Okay? So when I was doing up the presentation and when I saw this, it actually reminded me of my very first student at DAS. His name is Dexter, and when I first got Dexter, he was primary 2. And he had actually graduated from the preschool program and has moved on to the literacy program, but he was still struggling very much with English and as well as mathematics. So when I was talking once with his mom says that, Dexter will cry every morning, it's time to go to school, he will wail and refuse to go to school. So as his educational therapist, I decided that I have to do something to help people like that. So that was why I decided to specialize in maths as well. Okay, so now that you have a snippet of what it's like to be dyslexic, I'm going to go a little further to explain what are some of the other difficulties that people with dyslexia experience. Okay, so I'm sure you have heard throughout all the other presentations today that dyslexia is a neurologically based condition. And it's characterized by a phonological deficit, which means that they have difficulties processing even the smallest unit of sounds in language. And that makes reading and decoding difficult. So if you can't even read single words, or you are finding it very difficult to read single words, then it's even harder when you're asked to comprehend at the sentence or text level. And that's the difficulty that our kids face when it comes to things like word problems. It's like, oh, so difficult to read. Now you ask me to solve the problem and understand what the problem is about, right? But that's not the only problem that they face. Now, research has shown that there's a close relationship between phonological processing and arithmetic fact fluency. So arithmetic fact fluency means the ability to retrieve your math facts from memory. So things like 7 times 6 is 42 is difficult for them. Okay? And this is because in order to retrieve something, you need to first store it. And when you are trying to store your math facts into memory, you're making use of what you call the verbal code. That means you are actually trying to say it out like 7 times 6 equals to 42, right? And that's something that our students with dyslexia have problems with because of their phonological deficit. Well, other things that they have problems with include working memory, organization, planning. So problem solving is difficult for them. And they have problems with ordering their steps when it comes to multi-digit operations. So for example, if you're trying to add 2-digit by 2-digit, they would find it difficult, especially when it comes to with regrouping. Okay, if you think about 2-digit times 2-digit, that's a bigger nightmare for most of our kids because they have to retrieve the information from their head, which they are already struggling with, and then they have to put them in the correct place and do multiple steps. In mathematics, we also require the students to monitor their thinking. But because they are already doing so many things, this is a step that they often just neglect altogether. So you will see students when they are doing their work, after they finish, they refuse to check their work because it's already so tiring just trying to do it in the first place. Okay, and finally, the secondary deficit that you will get from dyslexia is the visual perceptual issues which you have already experienced firsthand. So moving on, when people first think of mathematical learning difficulties, the word that first pops out in their head is dyscalculia. However, there's research to show that dyscalculia is not the same as having dyslexia and mathematical difficulties. In fact, the experiences of people with dyscalculia and people with dyslexia and mathematical difficulties are quite different. So for dyscalculia, the deficit arises because of a numerical processing deficit, which means that they are unable to automatically and intuitively process numbers. That means if, let's say, I were to throw a dice and I were to ask you, oh, what's the number on the dice? They would literally have to count the dots and tell you 1, 2, 3, 4, 5. There are 5 dots on the dice. Well, it's very, very automatic for us when we see a dice, we know that there's 5 dots. Okay? For people with dyslexia and mathematical difficulties, their deficit is more to do with their phonological deficit. So the difficulties that they're facing has got more to do with arithmetic fact fluency, multi-digit calculation, as well as with problem solving, even at a single sentence level or a multi-step level. Okay. However, that said, dyscalculia and dyslexia can happen together. So when you have both profiles coming together, their deficits are actually additive, which means that they have more problems as compared to having just dyslexia and math difficulties or just dyscalculia. So it's more difficult to remediate in that sense. But for today's presentation, I'll just focus on people with dyslexia and math difficulties. Okay, so just some statistics for you. Currently, there is no international numbers to talk about the prevalence of dyslexia and mathematical difficulties, but there has been studies that are trying to estimate the prevalence of reading difficulties as well as math difficulties. Okay, so the latest that I can find was in the Netherlands, where they found that about 7.9% of those that have reading difficulties also have difficulties in mathematics. Now, locally, there has also not been any study to find what is the exact number of people who have dyslexia and math difficulties. But here at the DAS, we do have enrollment statistics. So what I'm going to show you next is based on our own enrollment statistics. Okay. So in the DAS, we have about 9% of students. Oops, the number is not coming up. We have about 9% of students who have dyslexia and mathematical difficulties. Okay, but this percentage is actually below, I would say below the actual numbers, because it doesn't include people who are in secondary school, because the DAS Maths program is not ready to support the students in secondary school in math yet. It also doesn't include the students who are not enrolled on the Maths program because of logistical or financial reasons, like if they were not able to come for lessons because their parents are unable to send them. And it also doesn't include the students whose parents have chosen to let them attend outside tuition instead of coming to the DAS. So this 9% is actually an underestimation, I would say. Okay, so, but 9% is still quite important. So what we try to do here is we are trying to effectively support our students who have dyslexia and mathematical difficulties in the following areas: conceptual understanding, procedural skills, and mathematical problem solving. Now these three areas, out of these three areas, procedural skills and math problem solving has already been found in research to be one of the key areas that people with dyslexia will struggle with. Conceptual understanding, on the other hand, we got that from the parents' feedback. As in, there were parents, before we started the program in 2009, we gathered feedback from parents to ask them, what kind of help does your child need with math? And we had many of the parents tell us that, my child doesn't understand what's going on in school when it comes to math, and they're struggling with it. So we decided that we should also teach the conceptual understanding of mathematics. Okay, so what is the program like? Well, the students, before they join the program, they actually profiled the Maths core team at the DAS, together with some of our contributing members. We look at the students' performance in their school exams to ascertain what the child needs. Okay, and after that, they are placed into a class of 4 where their abilities are similar. Intervention is conducted 1 hour weekly, and they are conducted by teachers who are trained. Now, these teachers have at least a year of experience in teaching literacy to our dyslexic students at the DAS. Okay, so what are they trained in? Well, first of all, they are trained in the Orton-Gillingham approach, which I think you might have heard over the past presentations, but just stay with me for the next few slides. Okay, so there are 6 principles, and I'll explain how they apply in math teaching. So first, we have cognitive, which means that when we teach, we present the students the things, and we get them to think about what is it you are looking at, And we get them to also talk about how is this related to what they have learned previously. Okay, so then that's the language-based part. We also teach them explicitly the language of math, because math itself, although it's taught primarily in English in Singapore, it is a language on its own, and some of the terms are used differently than you would use it in English. Okay, it's multisensory, so we have concrete manipulatives that we use to teach math. I'll explain more later. Oops. It's structured, cumulative, and sequential. So we start from the easiest concepts and we build up to the more difficult ones. We diagnose our students' needs. And lastly, it's emotionally sound in that we don't give them too much work to do so that they get too stressed, and yet we stimulate them enough so that learning takes place. Okay? So moving on, I will go to the teaching approach, which is the concrete representational abstract approach. Now, these are not 3 different steps. They are actually interrelated. So what do we mean by concrete? Well, we first present students with objects or manipulatives that they can physically touch and move around so that they discover and learn the concepts. So for example, if you are introducing fractions, we have the fraction tiles available. And we get the students to note about the special features about the manipulative. So for example, if you were to look at the fraction tiles, you will see that each of the rectangles actually have the same length, but they are broken into equal parts. And that's important because once they move to the next stage, they should see that those features remain the same. Okay? So at the representational stage, they move on to mental manipulation. So no longer use your hand and move them around. Okay? And then at the same time, we can also introduce the abstract stage where we bring in the formal operations. So for example, we want to do 3/4 minus half. Okay? So students will have to first represent what is 3/4. So you start with a whole, you break it up into 4 equal parts, but you only shade 3 because you want 3/4. Then you want to take away half. So you introduce another whole, you break it into half, right? Then what does it mean to subtract? Subtract means to take away. But at this point in time, the students need to know that you cannot take away units that are not equal. They are not the same. In the formal operation, you would see that there's a multiply, right? You need to multiply by 2. But students don't really understand why they need to multiply by 2. So then we help them to see that actually half is the same as 2/4, right? So you can, and to get 2/4, you need to break the half into 2 equal parts. That's why you multiply by 2. And so you'll get 3/4 minus 2/4, and you'll eventually get 1/4. Okay? So they need to see the relatedness between the 3 stages. And that's how we teach concepts and operations. Then there's another part in mathematics which got to do with problem solving. So at this point, we introduce to them the Polya's problem solving approach or process, which basically are 4 stages that students need to go through in order to solve the problem. So first, we teach them to understand the problem by breaking it into smaller chunks, like a sentence. We get them to act it out so that they know what the problem is about. Then they make a plan, usually by drawing the model, and then they carry out their plan and they check their solution. Okay? Now this is a iterative process, which means that at any point in time, you can move backwards. So like if let's say you are trying to make a plan and you carry out the plan, but the plan doesn't seem to work, you can always go back and try a different plan. Okay? So the following is our lesson structure. So as I mentioned just now, lessons are 1 hour per week. So we start off with 10 to 15 minutes of review of what was previously learned. Then we introduce the new concept using the CRA approach. And then there's practice and application. So application would also mean application into word problems. That's where Polya will come into place. And finally, we end the lesson with a summary so that students consolidate their learning. So at this point in time, I just want to talk about the study that we did to evaluate the success of the program. So the participants for this study are 45 students between the ages of 7.5 to 11.5. So at the point of study, they were in primary 2 to primary 5 standard. And because they were failing their school exams before they joined us. And our selection criteria was that they needed to be about 6 months on our program to be included in this study. We tested the students on an in-house designed battery of tests. We used a repeated measures design, which means we tested them once and then 6 months later to see how they're doing in the test. Okay, so the test that we designed, we broke it up into their level, so that each class level actually they have their own test. Okay, and we only tested them on the topics that they learned in that year. So these are our findings. Very positive. We see improvements across all the topics for all our students. And however, we also found a negative relationship between the age of the students and the amount of progress that they made, which means that the older they are, the less progress they made. And we tried to think of why this might be so. So there are 3 reasons. First is the complexity of concepts that are taught across the school years. So we have students who join us at P4 or P5, depending on when they were referred. And but they are performing below their chronological age, which means they may be at P2 level when they first join us. So although they are making progress at DAS, but in school they are learning more difficult concepts. And so they're still not coping in school, even though they are making progress here. That begs the need for early intervention, which means that if you notice that a student needs maths help, you should start them as soon as possible instead of waiting, okay? Because the difficulties will just compound themselves. Lastly, it's also the order of the concepts that are being taught at school. So, for example, in the Singapore system, the Ministry of Education actually designs and decides the national curriculum. However, in schools, the schools have the autonomy to decide which topic to teach first. And that becomes a problem when it comes to DAS, because we have students from different schools and it's difficult to know which one should I teach first. So instead of going by the school's pace, we go by the student's pace, okay? And so because what they're learning in DAS is not the same as what they're learning in school at that time, so their progress may not relate well to each other. Okay, so some conclusions. Firstly, I think based on the results, we're doing a very good job. So a pat on the back for all our maths educational therapists. It also shows the importance of having evidence-based remediation, because all the structured cumulative things and the multi-sensory approaches do work in our program, and we do see the results. It also agrees with what we've been hearing from parents, teachers, and from the students themselves about the progress that they have made after joining our program. There are 2 things that we need to note from this study. That is, our students do need a lot of review. And it's not just review from the previous lesson, but also from topics that they have learned maybe even half a year ago. And lastly, students need to see the interrelatedness of the topics across the topics as well. Okay, so some areas of improvement, we would like to have a situation where we have a control group so that we can see whether our intervention works even better with not having any other intervention at all. We also like to have some better control of extraneous variables, such as whether our students receive outside tuition other than DAS. Okay, and because this was our first study, we would like to see how the progress would map out over a longer period of time. Okay, so thank you very much for listening. I'm sorry I took longer than my allocated. Yeah. So for more information, you can visit the poster at the exhibition booth outside. Yeah. Thank you.
Thank you very much, Rebecca.